Hello, everybody. So tonight, main topic tonight is a very, very useful one. I will go ahead and start by writing the label for the notes on the board. Persistent data. An incredibly important part of developing software is we don't want to re-enter the data every single time. As programmers, we're working in RAM and registers, but the short-term volatile storage, which means it's only there while the program is running. When we get to the end of the program, all of that data we used in it just gets deleted. So it's really, really nice if we don't have to enter that data again completely, or so that our software can save stuff, or after we go over the syntax and look back at that example that's been building up, that payroll example, people's name, at least for our example, people's names and rate of pay is not going to change. So heading into your software development career, please remember that people's names in our society. So make sure you remember that it's possible to change names in our. Make it possible for people to change names when you put your software together. A lot of people have overlooked that over the years, and it can be a bit of an aggravation for some people, some folks. Before we get into that, though, I've been carrying this note around in my hand for like 20 minutes and doing everything one-handed. So I got to talk about this the other day. One of your assignments this week is to propose the project you want to make for this course. What's a piece of software you want to make? So this is week 3, we're almost, middle of week 3. So you have 4.5 weeks. So it needs to be something that fits in 4.5 weeks. And in general, especially at this level, usually people have something that in mind they want to do. So it seems like just about every time I've ever had to turn down a project idea, it was because it was too big to fit in the time constraints of the classroom. I haven't yet had to turn down an idea because it's too small. Like, you can do something much bigger for a semester project. Usually people suggest really, really big ideas, and sometimes I'll look at them and be like, yeah, there's no way that's going to fit in an 8-week course. That's about the only reason I've ever turned down projects. I might make suggestions. I will definitely make suggestions. It's unlikely that you won't hear that I won't make any suggestions on your project outside of this. But what I asked for is sort of the professional version of it. So in general, I'm not a big fan of templates if I'm doing my own work when this pulls up. In general, if I'm doing something to a client, I'm going to start from scratch and make it all entirely. Not a big fan of templates. Everybody has different opinions. Resumes are a great example, and it depends on the person, right? For some companies, for the hiring manager, you open up Microsoft Word, choose that first default resume template, and fill that out. And the hiring manager is going to look at that and be like, "Oh, a template. I know how to follow the proper form and just go through the motions and do what it's supposed to do." And really be really happy with the template, whereas other hiring managers can look at it and be like, "Yeah, the template," and just throw your resume right away, right to the side. So it's situationally different. In general, I don't like templates, but in a classroom, templates are wonderful. Right? A template document tells you what to write and where to write it. So those template documents teach you how to write the document. So I asked for one of those in the classroom. So go to Google and search for project proposal templates, which I'm going to search for twice because you'll probably already noticed the word that I left off there. Oh, right at the top, don't even have to click on them. We see there's a bunch of tags indicating that that's a very professional thing. Those templates that you pay for are a whole lot better than the templates that come with Microsoft Word. You get what you pay for, that whole thing. But for our class, don't go spend a lot of money. So make sure when you search for it, you include the word free. So search for a free project proposal template. And you'll see sometimes 10 best, best of. I'm scroll down a little because this one's the one I've been pointing at for years now. You'll see something from Smartsheet. They have some really good stuff. 17 free project proposal templates pulled up here. So Smartsheet has some good ones. There's a lot of other ones. I haven't ever used Project Manager, but just look around for a template that you like, which really is going to come down to one you like the colors for, right? Find one that you like the colors and font and how it looks. And for your project proposal, fill one of these out. So I'll grab this first one here as a Google Docs. Nope, just download it. I don't need a free trial or anything. It opens up in Google Docs. And they have some instructions right here at the top. To get started using the template, go to File and make a copy. The instructions right there at the top. As you can tell, I've done this a couple times. It's not editable yet, but if you go File, make a copy, and give it some sort of name to save to your own drive instead of theirs. There we go. We have the project proposal template. And now we can get rid of those instructions at the top because we don't need those. We already made a copy. And this is what I'm asked for in the project proposal. Actually, go find a professional project template, which really is going to come down to look through a few and find one you like the colors on. Your preference of colors, but they'll all have similar information. You might want to look at the information too. I guess that is kind of a big thing. And just fill this out. The project name, job location, and for our class, please make up some numbers. So make up a set. Just use your imagination to add a couple details, especially on those 2 lines that I stressed about when we were talking about making a plan. Remember?
Budget.
So how much does it cost? And what's the other one?
Budget and time.
Time. Yes. Yeah. Those are the only 2 things people are going to care about, right? You're going to fill out this big, huge project proposal. This one's, I think this one's kind of short. Yeah, this one's a 1-pager, 1 page long. So you're going to fill out this page, make it look really, really nice, with all these different boxes. But in the real world, these 2 lines right here are the only ones people care about. Okay? How much does it cost and when do they get it? And in a classroom, that's trivial. Right? The budget's 0. There's not going to be any money exchange for your final project. Don't go spending money. All you need to do is type up some code and type up some code that does what you want it to do. And the timeline is obviously the due date, which is the end of the semester. But don't be trivial with those. Get some practice with it. So the projected schedule would be, what is next Monday's date? The 14th? So 11-14 would be present proposal. 11-19, 5 days later, have basic design ready. So images and what your GUI is going to look like and jotted notes. So not something to give to the client, but the stack of jotted notes that you wrote down along the way. You always say it's spoofed in Hollywood. That thing, there'll be a writer sitting in their study, and the room is just full of all the papers that have started, wadded up, and thrown all over the place. Right? It's commonly spoofed in Hollywood. That is an important step. Don't skip it. The messy step. That's where we collect and organize our thoughts. So include that in your schedule. Give yourself some time to do that. I probably could have pulled out some pages that I don't need the notes instead of grabbing 3 blank ones. I didn't think ahead on that one. But make the schedule detailed. When's the project progress report due? It should be 21 days after that, which should be the 29th, I guess. I'm not going to check the calendar, but something like this. On the 29th, submit progress report. And some templates will have a progress report section. They'll have the proposal section. And then another page that has the progress report section. They go together. That way you can keep the whole project together and make notes back in the original about changes and things. So maybe look for one of the templates that has that and spell out the schedule very, very precisely. Let's say by 11, have everything made. And by 12:18, which is the end of the semester, then have debugging finished. You probably format it a little bit better there, right? Everything it's going into a table, so we can put a subtable there to organize it nicely. But think ahead and spell out what the timeline is going to be. Don't just say the December 18th. And actually put in the details like you would in a professional setting. Get prepared, get some practice for that, because you'll want to do that one of these days. That's why we're here at school, right? So you might as well get some practice at that. And then same thing with the budget. Obviously the budget is 0 since we're in a classroom, but make up some numbers. So let's say for one project that's a little over a month, so let's call it $85 depreciation on laptop or other equipment. Some accounting stuff. Depreciation is, we spread the cost out over time. So for example, if you paid $1,000 for your computer that you write code on, and you do 10 jobs with that computer, hopefully you're making $100 from each one of those jobs, so that you break even on that tool. Right? You make the money back to that tool. That's what depreciation is. The word sometimes shows up in normal English, and people that aren't accountants often don't entirely use that word correctly, but spread the cost out over time to make sure that your return on investment is at least break, or to see where your investment is going. I don't know, $350 for coding labor. That doesn't sound like the right words for it. Whatever would make that sound nice, but for the actual work of coding, then another $125 for testing. In a real project, you would probably have some marketing campaigns, right? Because you'd have that final presentation. You don't just want to say, here's your software. You want to make a big deal of presenting it to them. And it's like a big celebration. You have signs and banners and party supplies, maybe a big feast. Have the clients come and there's a big dinner and stuff. And just work that in there. I don't know, $75 for the marketing, and try to think of things that would apply to a real project. We are in a classroom, so just make stuff up. At that point that I was expressing there, the only way we get good at those two things is to practice it. So if you practice it on everything, and then at the end, come back and make the adjustments to your schedule and adjust and then the adjustments to the budget and then apply that, how far off you were to your next guess at a schedule and a budget. When you're out there in the real world, you'll be really good at predicting those two things, and people will take notice of that, because the general trend is just to go high, right? Bid too high so that people are happy when you come in under budget. But if you're just arbitrarily bidding high, you might miss some things. And then your high bid turns out to be too low anyway. Or you might miss some of the points in the schedule and get way, way off in the timeline. So it sounds early and under budget sound good when we think about it, but on time and on budget will give you a better reputation and assure more consistency in work and better reviews when it's time for an annual raise and all that stuff at the company. So it takes practice. So get some practice here. Make up some numbers. There won't be any money exchange for a final project, obviously, but y'all can make up some numbers. What's that add up to? 475, 550, and 85 is So a total of $635 for this project. We got doesn't take long to make that up, and you'll get some practice, and then on the next one, pay close attention to it, so that the next time you do one, you can estimate that a little bit better. And then the one after that gets a little bit better and a little bit better, because people will notice that. And otherwise, just fill it out. The other parts are obvious for a classroom. What's the project? Summarize it, describe what it's going to do, what is needed to make it happen, what sort of benefit will come from that project, who's involved with it, and who's involved with it and what's needed. So if anybody's had a project management course yet, that's their two big things, right? Our resources. We schedule where our resources goes, and that's all project management. So a spot for predict the anticipated resources we'll need ahead of time. Who signs off on it, and yeah, just fill out a template. That's what I asked for. Just kind of look for a free one that you like the colors on, seems thorough. You have a progress report due, and a lot of the templates do include a progress report, so that you have that side-by-side comparison from original proposal to how it's going. And those, so maybe one of those might be a good one to look for. But that's what it will be needed for your final project. It will have a GUI, graphical user interface, and it'll need to do, some sort of a small application. It doesn't have to be huge. We won't get to networking here, so it does have to run on one local machine. Networking first shows up in the 200 level class, but then we don't really start requiring it until the later classes. So around 200, the language specific, 200, 220, 240, whichever language you choose, you'll see networking for the first time. And then in the 265 or higher, then you're required to apply that, to like go out to the internet and grab your data, or your project needs to communicate to another machine through the internet. So that's still further down the line. So a small application that runs on one computer, and if you want to think of a point of sale thing, so like a pizza ordering system, that's a good one. Right? Make something that would run on the computer at the pizza place, what they need to order a pizza. Lots of different things. If you need some ideas, let me know. I can come up with a long list of suggestions on ideas. If I start into that now, I will just keep rattling off ideas and waste all our time, because we have something that's going to be important. This will be one of the requirements in your thing. It needs to save some data. So on that one I mentioned, without getting into the list, a pizza ordering system, you want to save it at least to a text file, or think of it like a text file, so you can print it out, and then there's the receipt and the order that the person on the phone hands to the kitchen staff that's going to actually make the pizza. So somewhere we need to save our data. That's an important thing. You all know about saving data, right? When we save stuff, we save it into files. And there's a small distinction, probably not going to show up for us, but I want to go ahead and talk about it right from the get-go, because there is a difference, in our textbook does kind of describe it in the wrong way. We, as programmers, we're in RAM, right? We're working in RAM. We're always in RAM. Files exist in storage over on the hard drive. Files do not exist in RAM. So we can often say that because it makes the sentences easier, and our textbook was bad about it. But what we actually work with is a file handler. So that's the first thing we need. Use a file handler to transfer data between RAM, which are standard UML diagram for that's a rectangle. Volatile storage is a rectangle for processing. From RAM to long-term storage. And the UML diagram for that is a stack of disks. I've heard the picture is supposed to represent a stack of the old reel-to-reel tape machines. Has everybody seen those? Because the next thing I'm gonna do is refer to one of those old reel-to-reel machines, because it's the best way to describe the difference between a file handler and a file. But we use a file handler to transfer those back and forth, not the actual file. We will see the file soon, because at least two of the people on this list, on the roster here, aren't necessarily heading to software development. They're just taking the programming class because it's going to pay off where they're heading. And they will need to work with the files. Working with the files is what happens if you open like File Explorer. We move it to another directory. We copy a folder and put it in another directory, shuffle things around. We work with the entire file at once, not the data in the file. Whoops. Dropped my marker and it rolled away. Let's see if another one works. That one's kind of lousy. That one looks good. So working with a file is like what you do in File Explorer. We don't actually access the data inside of the file. The best we can do on data is how big is the file? How much data is there? We can see that number, right? It's a 4 kilobyte file, but we don't know what makes up those 4 kilobytes. That's a file. We work with file handlers in order to get the data out of there. So to think about the difference, well, I like to think about those old reel-to-reel tape machines. So everybody seen those, like history books and stuff? The precursor for audio. So it's just what they were is just iron filings, like powdered iron, little shavings stuck in between two pieces of Scotch tape. It really was just a big pile of iron dust almost. They took some Scotch tape and stuck it down on there. So it picked up a bunch of iron, took another piece, stuck it on there, and then ran it past an iron to seal those two pieces of plastic together. So then just a bunch of iron between two pieces of Scotch tape. As like powder or little shavings and flakes, little bitty things that can easily be moved, like from a magnet. So as that tape which an inch or 2 inches wide, are the original ones. As it rolled between those two reels, there were two types of magnets that it would roll past. It's in a little bit, I think, on the camera. So it's full of all those iron shavings, and really there was one magnet, we just treated it differently, but I'm going to draw two for the picture. So there are two types of magnets that we can run that past. One of them is held stiffly in place. It's like locked in place, so it does not move. And the other one is on a spring. So it bounces up and down. And everybody's seen a magnet before, right? Like charges attract and discharge. Let me try starting that sentence. Like charges repel and dislike charges attract. So a north pole and south pole, a north pole pulls on the south pole and vice versa, south pole pulls on the north pole, or a north pole pushes on another north pole. So this one held in place, if we control the magnetic the polarity of that, which we do with an electrical signal. Electricity and magnetism are the same thing. It has to be drawn in 3 dimensions. Oh, looks like my marker's giving out on me. We can't even draw it in 2 dimensions, but let's see. Put it this way. So if we did the math and drew out a magnetic wave like this, so that we have I'll put north up here and south down here. So north and south poles of a magnet changing back and forth. If we do that, yeah, then coming in and out of the board here, we have an electrical field where that's actually backwards. Yeah. I'm going to change the south and the north, which I know looks strange, but I don't want to label it incorrect. I want to draw the picture accurately. So if we have south going upward and north going down, so just think about a globe turned upside down. Because the other one, we'd have positive electricity coming out of the board and negative electricity going into the board. So they go together. So that one's going straight up. Maybe I could put it in a different color. So going up and down, we have north and south poles like a magnet. And coming in and out of the board, we have positive and negative charge electricity. They create each other and propagate it. That's what a light wave is. It has both pieces. When we talk about magnets or electricity, that's the 2 pieces that make up a light wave. But they go together and create each other and affect each other like that. So we can use electricity to control what the polarity of this magnet is, and it's held stiff. It's not moving. So when that happens, those little iron shavings flip around based off attraction and repulsion of the magnet. Because iron's very magnetic. If we put iron near a magnet, it picks up that charge and becomes a little magnet itself. So it holds the charge, it holds the polarity of running past that stiff magnet. So that's our right head. So that's how we would write the data. We would adjust those signals so we have a bunch of north and south poles, and then that's preserved in that iron powder locked in between those 2 pieces of Scotch tape. And then later we can come back, and the one on the spring, we have that polarity. So from like charges repelling and dislike charges attracting, it causes that other magnet to bounce up and down. And then so we get movement out of it, and that's how we would read that data. And I like to point at this, which really would be one magnet. We'd adjust the connection to it, which we need, right? But it makes more sense in a picture with 2 magnets. So we could that's how we would change that, and then we would basically it's based off the distance. So the width of the actual magnet, after the normal horseshoe way, when y'all have seen little square magnets, right? We have a square magnet, so the width of that magnet would be 1 bit. And then the tape would be like 1 inch or 2 inches wide. So we can do 8 or 16 bits across. So each little segment would have a whole bunch of little bits going across we could read. But that's how it would be organized on time. We could read and write that. And the file, the actual data that's stored, that's the magnetic tape, right? But as programmers, we're over here working in RAM. Well, I'll just write CPU. This is back in the days of like those powerful really hot vacuum tubes and a big radiator. You often hear it described as a computer was the size of a house. But a computer was never the size of a house. The computers, the biggest, were about the size of a desk. The radiator was the size of a house. It's really easy to heat things up. Every bit in RAM had its own little heater in it. So it's really easy to, y'all have seen electric heating coils, coffee pots, electric stoves, all that. Every bit in RAM had that. It's really easy to heat things up, to turn it on. Because heating it up would, there's another type of spring that just adjusted for heat. So with mercury inside of a glass tube, as something would flip up or down depending on how hot or cold it was, and the mercury would flow down, connect to the circuit, and turn the switch on. So the heat and cold was basically how we controlled that. It's really easy to heat things up, but it takes a lot more to cool them down. So a computer set about the size of a desk took a radiator the size of a house to cool it down quick enough to be able to use. It's really easy to heat things up, especially when you have electricity. Cooling things down is a little more difficult. But back in those days, that read and write head would be connected over to the CPU, and this is where our program is. So the read and write head is the file handler. It's the thing that can see the data. It's the thing that can react and let us know what data is stored there, which is different than the file. I think our textbook was really bad about it. They kept saying write a file. But if we're in RAM, we're not actually interacting with the file. We're only interacting with the file handler. The Zoom's acting weird here now. There we go. So a small distinction, I like that old example because it helps to visualize physical components, make a lot more sense of the difference between a file and a file handler. The file is what's stored on that tape. And the file handler, what we work with as programmers, that's like the read and write heads. The actual device that can see what's on the tape. And it's the same thing. We work with something that can see storage. It can see what we have stored in the file. But it can't do any file operations. It can't move the file to another folder. That's where we do that working with a file like we would in File Explorer on Windows. So there is a small distinction. It's not going to show up tonight, but in the long run, it will show up for you. So be aware of that distinction. With programming, we work with a file handler. And hopefully that analogy helps to kind of make sense of it. But it's an important thing in all of our programs. We want data to stick around and last. So let's see the syntax for doing this. I'll go ahead and jump into Spider, but there are lots of places to type and run and test Python code. So any place you want to type your code will be fine. I think a couple people had some trouble setting Spider up for various reasons. Different error messages show up and stuff, but as long as you have some place to write your Python code, it'll be fine. Oh, and I guess I didn't make it, I jumped a little bit ahead of our textbook. In this week's homework, you're doing functions and methods. The textbook uses the word functions a lot, but remember when you go to answer questions about it, we only have methods in Python. Functions are for procedural programming and methods are for object-oriented programming. And the book kept doing define a main method, and then you do all your stuff right there. The other day we talked about the guard statement. If name is equal to main, which really what that means is this the file we actually hit the run button on? Did we hit the run button on this file, or was this file just imported into the one we actually hit the run button on? somewhere down the chain there. Because we only want to run stuff if it's the one we hit the run button on. We don't want to run like all of our test cases when we import a file. Right? If we import a module in order to reuse a function in a different project, we don't want to rerun all of our test cases all the time. So what the textbook is using for the main method, that's what goes down here in the guard. So think of that down there, that part as your main method. So that is where the code, that is where the program starts. Do all of your, put all of your code and functions up here. And then think the program starts here. So then call all of those functions from that guard statement. One more thing, since I'm talking about stuff that I disagree with this textbook, there's more than one way to do that. The textbook just calls a pre-built method. We have lots of those in Python, right? So if we want to write a file, we give it some sort of name. I like names like toFile and fromFile, make it easier. And we use this open method. And open, we can see in the predictive text here, it needs what file is it opening and what mode is it opening for. So I'll open a file called test1.txt, and then the mode, there's a short list of options. We can either read a file, in which case we put an R, write a file and we put a W, or append to a file and we put A. So write is overwrite. If we put a W, it will erase everything that's in that file and replace it. If we put append, an A, it goes to the end of the file and adds more. Both write and append will create the file if it doesn't already exist. I'll just write a file. So that creates our file handler. Create a file handler. And then to do stuff, we can use that file handler. So once we have a file handler, we have some built-in methods for it, such as a buffer to close it. And close is very important. Have y'all ever started typing and your cursor was in the wrong spot? I knew right here, I'm pretty sure it's probably happened to some people here in Spider, right? I need toFile.write, so I start typing the name of that method, but my cursor's over there in the console. So it's in the wrong, I was typing in the wrong spot. But we're humans. We've all done that. We notice that something's wrong and quickly make the adjustments. We're an intelligent species. We can figure out something's wrong and adjust for it, erase those mistakes and move the cursor back over where it's supposed to be. A computer is not intelligent. If the cursor is in the wrong spot, it will do the work there. And that can be a little destructive, right? If we're in the wrong spot and just start going around changing things at random spots on the computer, that could end up destructive. So it's very, very critical that you close your files every time. Programming languages have a standard worked in so that if you forget to close your file, it will kind of error out so that you don't ever accidentally end up working in the wrong spot. So we always want to close it, but to write something, we can just call this write method. There's a couple of them, and then send in a sentence. Hello world, and then I'm going to do a line break at the end. If you're writing to the file, remember you want to put in line breaks at the end. Otherwise, you just end up with one big long line. Everybody's seen that in a text file, right? It shows up in our code. They have long lines of code. They just keep going and going and going. So remember to type it. You need to manually type in the escape sequence for a line feed. Hello world, and I'll do at least 2 lines, right? More words, and I'll just end it there. So that's all that's gonna be written to the file, then remember to close it. Which I just made a big deal about putting that in this, didn't I? I'll paste that down there. Okay, stepping aside for a second, because I don't like to work at the bottom of the screen. So just adding some extra lines there at the bottom so that I can scroll all the way down to the bottom of the code. So that's what the textbook often shows. There's a better way to do it. Actually, we're talking about methods this week, so we should probably put that in a method, huh? Because this will always kind of go together. So I'll write define a function. This set of instructions goes together, so we might as well make a collection of instructions, an instruction set that we can ask for anytime we need it. Really just once here, but simple file writing. I'll call it that, and then I'll copy and paste all of this up here. Create a file handler, write text to the file, and close the file. That's our basic process. So then down here in our card, we can call that statement, call that function. Simple file writing, and go ahead and save this. I'll just call it files.py. That's a good name for it. When we run it, there's not really any output. The only reason we got any output at all is because Spider has echoes turned on, but it tells us that it ran the file. Which that command right there is the instruction to write a file. So if your final project would involve making a run button, it's going to look like that. This is the one they made when they built Spider, but you'll make a method like that and it only has 3 lines in it. It's very, very short. And then just a call to that method is all it takes to, if you need a button that runs code. But Spider has echoes turned on, otherwise we wouldn't have any output. If we go over here to where that's saved, notice when I put in the name of the file, I didn't give any sort of address. I didn't say go to the C drive, user folder, documents, or anything. If all we put in is the name of a file, it goes to the same location. If we want it to write somewhere else, somewhere specifically, we can just put the whole address on there. C drive, users folder, whatever the user is, the right to the downloads folder. Or I can come over here. Where's my file explorer? I guess I closed it. View and turn files back on. There you go. So we can see in the same folder we have this text file now. So there's the words. Just send those words over there. There's a better form, and it's going to relate to that thing I kept saying the other day. Sort of the general Python syntax. We have a keyword followed by something unique to our situation, then a colon, and we indent everything that goes with it. Or we see it down here. The keyword followed by what's unique to this particular situation, ends with a colon, and then we indent everything that goes with it. That's what I feel is just sort of the general Python syntax. There's one of those for file writing as well. And our textbook doesn't show it, but it's a little bit better, a better way to write files. So I want to make sure I show it up, make another, find a better way to write files. So I'll basically do the same thing. Actually, I'll copy from up above and I'll copy the stuff from up above because we need the same instructions. It's just a different order. And our keyword is with. So we use the word with. And you can see it turn purple there, like if and def, the word from Python. And then we can open it. So with, and then that method creates a file handler. So with some file handler as, I'll give it the same name, to file, then a colon, and we indent all of the stuff that happens while that file handler is open. And we don't have to worry about closing. That's the biggest advantage of this, is with will automatically close the file when we're done. So we don't have to worry about that. So I'll just write a couple lines. Actually, I'll go to append now. Well, let me write first. Improved file writing. Another set of words. If we look at that text file, we can see what's in it. It has that the stuff from the first pass there. I'll close that. And now comment this out and call that method. Better way to write files. And notice that I didn't tell it to close. So close is built in with that with keyword. So with is for working with things like file handlers, needing to close and all that. So our textbook doesn't show that, but you can see it's the same instructions, just in a slightly different order. We're going to make a file handler, create a name so we can refer to that easily in our code. And then we have that keyword, but it follows that Python syntax. A keyword followed by something unique to this situation, ends with a colon, and then we indent all the stuff that goes there. I like that better because it's, well, it has the advantage of there's some built-in error protection there that we would have to manually do. Not a lot, but just a few basic things. And it seems to follow that general Python structure a little bit better. But when I run this now, again, there's no output here. So if I look, the output is over in the text. So notice the write method deleted what was in there and just wrote new stuff. This is to make, so you all have stuff to reference. I'll just go ahead and keep making things up. Add to a file. If I want to add some stuff, we can use the A for append. We want to append some words onto the end of that file. More stuff appended on. And I will be doing it this way in class because that's what I'm used to doing. Our textbook only does this, but there are a couple other issues with that. Either way will be fine on your homework, but I would highly recommend this one because overall this is a better, there's stuff going on in the background that makes this way a lot better. So might as well start with it from the beginning. And I think it follows that general Python structure a little bit better. A keyword, unique situation, and then the end. whole bunch of stuff here. So that one already ran. So we saw that write just overwrites it. If we do the append, or if you wanted to, I have heard some people when they write the A there, it stands for append, but they just go ahead and call it add while they're speaking out loud or thinking out loud or that sort of thing, because it does fit there as well. Add to the file. Close the file so we're not, oh, actually, let me leave that open. I'll leave that file open. Then when I run it, notice it just added some more stuff appended on it, went right to the end. So there was no line. That's what happens if we don't explicitly say put a line feed there. There was no line feed to go to the next line, so it just went to the end of the file and just started adding stuff immediately. So pay attention to things like that. So Spider didn't mind about that, but over in, how's that error now? No. If I open that with Sublime and append that stuff on there again, Sublime doesn't mind. Some text editors will panic. It'll be like the file has changed. You'll go back over here and then there's a big error message. It said another user has changed this file while you're working on it. I have two decent text editors pulled up here, so they don't mind it. And both of those do also count as IDEs. I tend to call all of them text editors. That's what we're really doing with them. We're just editing text. And there's a lot of stuff we can do with basic text. So as we add more and more buttons and extend it into what you would generally, what you probably first thought of with an IDE, like the difference between Notepad and Spider here. There's still just a place to write text and a few buttons that'll be useful. I still often call them, all of them, text files. Reading is very, very similar. Read from a file. And so we need to open a file handler. And the file we want to open, test1.txt. Only this time we want to open it in read mode. And I'm going to call the file handler from file. Logic's very similar, we're just going the other direction. And instead of a write method, we'll use a read method. But we don't really know how much it is in that file, right? I'm going to erase it and clean up those lines. Bless you. I'm turning all these back on for a second. That way it'll kind of start over. Well, and I'm going to put line breaks on all the end of those. We already saw what happens if we don't. So basically, remember to put a line feed on every line you send to the file. Otherwise, things can get there. So we wrote some stuff, overwrote that, and then appended to it. Just did it all at once here. But we might also want to read from a file. So I'll comment these out in the example. And it's very similar. We open a file handler, give it some sort of name we can reference. And then from that reference value, just like we had we have a lot of methods strung onto here. Load stuff into a buffer so we don't need the whole file at once. We can do just little sections. Could flush. That's like a reset of what we're looking at. Name, new lines up. We can read from the file. Read all, read with buffers. Or what we probably want to do is read lines. We write stuff to the file one line at a time, and we'll read stuff one line at a time. Is there a right line in Python? Yeah. So why don't we start here? Instead of write, I'm going to use write line. That way it includes the line break. And starting off working with this, do the same thing when it comes back to read line. But here's a slight difference from when we write the lines. Our program knows how many lines of code, how many lines of text we're sending to the file, but our program doesn't know how many we're getting back. And this is the actual use of a for loop. That range function that you've probably seen a bunch of times, right, where it gives a number for I in range of 20, we count up to 20. That range function is fairly new. Well, relative to Python, it's like 6 years old now. But Python's like 35 years old. So 6 years old in a 35-year-old language is fairly new. So being able to count in a for loop is a new thing. First 25 years of Python, we did not have that. What a for loop is what we usually call a for each loop in other languages. So what we can do is look at how our stuff splits up. So a text file naturally splits up into lines. So if we just tell Python, look at this text file, it's gonna look at it and it naturally divvies it up into a bunch of lines. So that's what a for loop is intended to be used with. They added the counter so that the loops were fully interchangeable and we had alternatives to do stuff. But when a for loop, you want to think for each. So our general rule of thumb is while loops are when we don't know how many times it's going to run. A good example of that is the computer controlled thermostat. And we know the AC is going to kick off when the temperature drops below 72. But we have no idea when the temperature is going to drop below 72. In the middle of July, it might not drop below 72 all day long, or the whole month long, really. But well, this time of year is a good example. This afternoon, the AC might have kicked on because it got up to the mid 70s. And this evening, the heater is going to kick on because it's going to get down to the 50s. Right? We don't know exactly when that's going to happen. It's an actual measurement. So a while loop will just keep us going until that criteria is met to turn on the air conditioner or off the air conditioner or on the heater or off the heater, whichever one's appropriate for the temperature. But a for loop, which I kept using those words, for each, and indicates the thing. We want to use those for things that are iterable or countable. And countable doesn't mean we know the number. It doesn't mean we know there's 20 things. It doesn't mean we know there's going to be exactly 97 things every time. We don't know what the count is, but we know it's possible to count it. And that means it has a definite start and a definite end. We know there's an ending point to it. A while loop may never have an ending point. So countable just means we know it will end eventually. So for each, we'll iterate through the thing we're looking at. And in this case, a text file, so I'm going to call it line, because that just makes sense. So for each line in what the file handler sees. And it's back to that distinction I was writing about on the board. We're working with the file handler, not the file, because we can also hide stuff from a file handler. We can keep it out of there. We can't set up ignores. That's a different issue. We won't get to that in this class, but we can hide stuff from a file handler. We can't hide it from the file itself. Or vice versa, we can also hide files. And the file handler would still be able to read every bit of data in a hidden file. Python is installed in a hidden folder on your hard drive. So the folder's hidden, the file is hidden but the file handler has no trouble getting to Python. So that slight distinction. And the file things exist in the file and the file handler can see those things. Or we can hide things from the file handler, but we won't do that in this case. So now we renamed each line one at a time. So that's how we split up a text file. So that for loop is going to be for each, however a text file splits up. Line makes sense for that name because that's what naturally there. So we're going to grab the first line, bring that back in, and while it's here in our code, we'll call it line. Oops, and read that in. But we're getting something, so we need to put it somewhere, right? There's a couple places we could put it. One good place might be into a temporary string. I'll make a string called temp. And then all the way through this, we'll add it to that temp. Temp is going to concatenate on whatever the next line is. So then we'll have all those lines of code from that file. And then for the first run, I'll just print out what temp is. We'll just look at them, but we'll clean them up a little bit more. Oh. I made a typo somewhere.
Do you need a print at your fourth line?
I don't think so. String object has no. That shouldn't be a string. For line and. Oh. Sorry. I put the read line in the wrong spot. The file handler is what can read lines. And then when that file handler reads stuff, it gets us a string. Read lines, and then it'll just read all the lines in the file. And then we split them up one at a time, go through them one at a time. Then we'll add that to this temporary string and print that out. Okay. I got the lines and just read the file. Why are we only getting the last one?
Move your print line forward one, and it'll print all of it.
Yeah,
It did for me once I moved.
sorry, that's what I meant to type. I kept adding them, but I only printed the last one. So now we should see the whole file. I think that was a result of talking and typing at the same time. So we can write the data there, read it back. Was that you, James, that said that? What he was mentioning is like what we call echoes. We print that line each time through the loop to make sure we to see what's going on along the way whenever we hit a problem. I just typed the word, I just typed the wrong word because I think I was talking and typing at the same time. Typos happen. But that's the steps for reading it. So for each line and what that file handler can see, I'm just going to go back to simple read and write. Don't worry about the word line for now. and manually put in your line feeds. Because every language is different. We do want to generalize things sometimes. So some languages we will have read line and write line. In some languages, all we'll have is read and write. We always have read and write. The line, anything extra is specific to the language. That's the way I usually do it and deal with it later. So we have all of that stuff. It's got the line breaks in it and everything. Comes in right back like it was. Be useful in this situation. But if I point at the label I wrote on the board to start off tonight, I didn't mention text files. I specifically was talking about data. And that's the sort of things we want, right? Like if we have our payroll calculator example we get to in a little while, we want to be able to save everybody's name and rate of pay. And not only that, when we bring it back in, we want to make sure we have the correct name and rate of pay for each particular person. There's different ways we can do that. And whenever this pulls up on the screen, there we go. The example we had here, basically, if we wrote it to a file, we'd have to read it ourselves and re-enter that data, which isn't quite what we want. We need a way to get each data point, not just in a file, but in a file with some sort of structure so that we can retrieve it. So after a break, we're going to look at 3 of the most common ways to do that. Maybe a 4th way, but I think we're going to run out of time on the 4th way, and the 4th way is 3 will be good. Our book only looks at 1, but there's some better ones that we might want. So that's our basic syntax, but let's look at a better application of that syntax for purposes of what we would actually call data as far as our software needs it. Our particular program that we're working on needs data points, not just saved, but it needs to store and retrieve them. So we need structured in a way we can get back there. But first, we should probably take a break. 10 minutes sound good to everybody? Got head nods here in the class. A very quick set of head nods here in the classroom. So my laptop, that's the clock I'll look at, it says 7:08. So we'll get back to it at 7:18.